Yes. Hello, everybody. Are you live? Yep. Okay. Hi, folks. We are Red Tech, and we have partnered with Google Student Developer Club, University of Belgrade. Big shout out to those guys. We're a couple of undergraduate students here at School of Electrical Engineering, University of Belgrade. And today we'll be starting a 5-lecture event called IT Isn't Rocket Science. Today marks our first lecture, and there will be 2 more on Saturday and Sunday, also at 6 p.m. And I'll be your host on the next one as we cover Spring. And my friend Mattia will lecture you on quantum computing. And on next Thursday and Friday, my friends Mladen, Milan, and Damian will cover 2 more AI topics or ML topics. Find out more about our lectures in the description below. So let's begin with our topic for today, and let's introduce ourselves.
Hi everyone, I'm Andrija Lenkovic, a student of Department of Signals and Systems and a software engineer at Logicon. I'm a computer geek and a gamer, and that's what got me into programming. Today, I'll try and show you what it is that I do at Logicon daily.
And hi everyone from me again. I'm Georgi Dimitrievich. I'm a software engineering intern at Algo Tech. Also, a shout out to those guys. And I'm currently studying computer engineering at University of Belgrade, School of Electrical Engineering. And I've been surrounded with video games and computers basically my whole life. I've been a computer science enthusiast since early age, and I'll try to pass that enthusiasm to everyone that's listening to us today. We're going to talk about .NET Core and how to make REST API in 1 hour.
Okay, first we're going to start and tell you about something about REST and what it is, how to use .NET Core to make a REST API. Then we'll talk a little bit about Entity Framework and how it helps us to communicate with the database. And finally, we'll
start from scratch and show you how to start making a REST API. But for now, let's see how it all looks like.
Okay, so this is our app. This is a table of products that we have. So for example, we have 2 categories for now, cars and clothes. And here we can see all the products that are in our database.
Currently.
Yeah. If we want to add a product, we would type in a name, we would select a category, and then we would type in a description and click submit, and it will show up here.
Yeah, so just so you know, this is a live event, so we want your interaction with us. So if anybody has a favorite car, please type something in chat.
Yeah, we have a bit of
a delay, yeah.
So we'll wait to see, probably like 5 seconds, 10 seconds. Okay.
So does anybody have a favorite car? We want to enter something just so that we can show you that this actually works. Anybody there?
Yeah, I don't see anyone in the live chat.
Nobody. Okay. We'll do it on our own. So write something. Write a car.
Yeah. My favorite one is the added. Okay, so as you can see, it was added here and it's displayed.
Yeah, so now let's go back to the presentation.
Okay, so first let's start with a REST API. What is REST? REST stands for Representational State Transfer. The idea of REST is that we will have a client that uses our API and a server that takes some requests. And the idea is that the client would provide all the data that the server needs to process the request. The server can't have any, can't save any state in it. And that makes our API easier to implement. It's a software architectural style. So it's not bound to HTTP, but usually it's conducted over HTTP. We have a client that sends in a request on some URI. It has a method, a header, and a body, some headers and a body. And our server then processes that request and returns a response.
Yeah, and the response is usually in JSON or XML, but that's also not mandatory.
Okay, so now let's move on to .NET Core and Entity Framework Core. Okay, so .NET, today it's called .NET, but before it was called .NET Core. Basically, in like 2000s, when Microsoft made C#, they also made the .NET framework. And this is a framework to make applications, web application, desktop applications, even mobile applications for Windows Phone. And it had one major flaw. It could only be run on Windows.
Yeah.
So Microsoft decided to release .NET Core in 2016 that will fix this problem. .NET Core is a cross-platform software framework. So that means that it can run in any environment, be it Windows, Linux, or Mac OS.
Yeah.
It supports C#, F#, and Visual Basic, and it comes with CLR, or Common Language Runtime. That's your C# .NET equivalent of the Java virtual machine. You have C# code, for example, compiled to intermediate language and then interpreted on the virtual machine.
Yeah.
You also have modern features like just-in-time compilation, so that the CLR can decide whether some intermediate language code is compiled directly into bytecode to speed up the application instead of being interpreted on the virtual machine. It also comes with a NuGet package manager.
Yeah, but we'll talk about that later. We'll show it to you how it's actually used.
Yeah.
Okay, now let's speak a little bit about Entity Framework Core and what it brings to .NET. It provides two things that are super important for us. One is ORM or ORM. It's object or relational mapper. So back before Entity Framework, you could have connected a database to your program only through one way, and that's a database first approach. So you would go into SQL Server, make a table, populate it, and then somehow connect it back to your code. Now you can do something else, and with ORM, you'll have a virtual object database that can be used from within the programming language. Why is that good? Why is that an advantage? You wouldn't have to have someone who is really good at SQL to operate your databases. You will only need someone who is good at a certain programming language. So for example, this works in C#, works in Java, works in Python, works from any of your favorite programming languages. And the second thing is code first. What does that mean? It means that you can actually only use code to populate the entire database. So you can make your database inside the code. Like it says here, it goes from domain classes through the entity framework and maps all your classes into database. That's why it's super useful for us.
Okay, so migrations are what enables us to use code first. The idea of migration is that we have some C# classes or some C# code that when we run it is translated into an SQL script, and then that script is run on the database. Now, Entity Framework can also generate these migrations automatically based on your domain models or classes. So essentially, you just need C# classes that represent your database tables, and you're ready to go. Entity Framework will do everything else for you. That's why this is what we are going to use today, because it saves us a lot of time on what essentially is boilerplate.
Yeah, we'll show it to you later. Okay, now let's talk about also two important things. Those are dependency injection and inversion of control. So inversion of control is a design principle, although some people refer to it as a pattern. As the name suggests, it is used to invert different kinds of controls in object-oriented design to achieve something that's called loose coupling. And what about dependency injection? Dependency injection, like I want to short this. You can say that you need some class and you need it to do something in order to work. So, for example, you need to work with a database, so you need a database context. And you don't care about how it works, you only care about the end result. So like it says, inject some objects into other dependencies. So moves responsibility on managing components to somebody else. Actually, we can tell you an example, that real life example.
Yeah, so you can think of it as, let's say if you wanted to go from point A to point B. you could drive yourself with a car, or you could pay the taxi driver to drive you there. Now, paying the taxi driver would be an equivalent of inversion of control, because you're not concerned with driving yourself there. You only want to go from point A to point B. You don't care about how you get there. You don't want to do that yourself. Yeah. That's what inversion of control is.
And we'll actually show this dependency injection in code, just because some people get confused.
Okay.
So now we'll show you a little bit what we'll cover today and what we'll be actually coding. So we'll make a product catalog API, and we'll show you how to start from scratch. We'll show you some basic CRUD operations. CRUD stands for create, read, update, and delete. So those are your basic database operations. And just so you know, this is only a proof of concept. So this won't be a tutorial or something else. We'll show you how to start, and we'll actually add something. We'll add a feature to a code that already works. And it should take us about 30 minutes to do all of that.
Yeah. Okay, so this is what our database is supposed to look
diagram,
like. Yeah, so we have categories with a name, a description, and an ID. And we have products with an ID, name, description, and category ID. So category ID is used to connect our products to the categories. So every product needs to have exactly one category ID, or one category, and every category can have 0 or more products.
Yeah. That's so the point is that each product needs to be categorized, like in real life,
Yeah. Okay.
So now let's move into code. Let's open a new Visual Studio.
I will open a new window. So it's time to load a bit. Okay. So we will start a new project. Okay. I'm sorry, the PC is a bit slow. So here we will type in core, because we want .NET Core. When you install Visual Studio with .NET, it's also going to install the .NET framework.
Yeah, but we need .NET Core.
Yeah, these are templates, and we want an ASP.NET Core Web API template, because we want to make an API. Okay, let's call it products.
Products test.
Yeah, we don't have to test because.
Okay, sure.
Yeah. Okay, so we want .NET 5. That's the newest version. We want to configure for HTTPS, and we are not concerned with other things. We can leave everything as it is.
Yeah. Okay, let's start. Yeah, he's running a Mac. He's running a Windows, so that's why this is everything.
Yeah, I mean, and the Mac itself is not very fast.
Okay, now that we're in the code, we hope you see this. We hope you see this. It's a little bit smaller, but
yeah. So here we have basically this is our solution, and it also creates some, because this is an API template. It starts with some kind of a weather forecast API. So that's why we have this weather forecast class, and in the controllers file we have weather forecast controller. For now, we can delete these. We don't need them. Just wait a second. Right click, delete. Okay. Okay. Now here we have. This is how your solution looks like. Really, you have app settings.json. This is a file. This is a JSON file that contains all of our configuration information. So
all
that's
settings.
Yeah. So that's where we are going to keep connection strings for the database. We have these two classes. The program class is the main entry point of the program. This is what runs first when we start the application.
Yeah, usually won't be changing anything here. We'll leave it as is.
Yeah, and in the startup is where really all the magic happens. This is where we configure our application, to our needs. So you have basically two methods here: configure services and configure. So the configure method is where you would configure your whole application. So for example, if you wanted to use HTTPS redirection, this is where you would call that, logging and I don't know, some
stuff like that, yeah.
Application-based configuration. And in the configure services app, method, you are going to register services for dependency injection, so that the the application knows what to inject in certain classes.
Yeah, we'll show it. We'll show it to you later.
Yeah.
How it's all done.
We also have this dependencies tab. So this is where all your dependencies are. You have maybe some project packages, etc. We can right click on that and say manage NuGet packages.
Yeah, like we told you, we're going to explain how it all works right now.
Yeah.
So we need a couple of things. It doesn't come with the entity framework, right? So
yeah.
we need that.
Entity framework. So we are going to install that. We are also going to install, because entity framework doesn't come with database drivers, we are going to install PostgreSQL drivers for now, because that's what our database is. So yeah, I accept. And we are going to install the automatic migration tool for entity framework. That's entity tools.
Yeah, so we're going to need those three in order to start.
Okay, I think that everything is installed right now. Okay. Now that we've installed everything, let's build our, let's make a new folder that we'll call the data access layer. We are going to touch on why we are calling it that later, but for now, let's do this. And then inside that folder, let's add a new folder for models. This is where we are going to keep our classes. If we go back to the presentation, we would have two models: one class that represents products and one class that would represent categories.
Yeah, so, like we said, so we're mapping classes into our database table.
Okay, so we go add class. Just a second. Okay. We're running a ton of stuff here right now, so it's a
bit slower.
Yeah, it's slower than usual. Okay, so this would be our product class, and then let's create a class for categories.
Yeah.
Okay. So let's start with a category first. Okay, so a category has an ID. We're going to make getters and setters. It has a name.
Yeah.
Getters and setters, and it has a description.
Yep.
Okay.
Okay, and the product has the same thing, right?
Yeah, we're going to copy this into product. Okay.
Yeah, but we're missing one thing in product. We're missing a category. Like we said, each product needs to be categorized. So we need a category ID inside the product.
Yeah.
And there's actually one more thing that you can do.
So entity framework will allow us to, let's say, reference category that has the corresponding category ID in this model itself. So I'm sorry, I missed it. But if we take this property that's a type of category, and it's called category, the entity framework is going to populate it with the category that has the category ID of the corresponding product. That's the idea. Same thing
in categories.
Is in categories, but this, because categories can have more than one product, we are not going to have a product here, but rather a collection of products. That's why we use iCollection. That's an interface that provides us with a collection of some classes. Let's say product. Products.
Okay.
Products.
Sure.
Okay, so now we've made the models, but we still haven't told how entity framework is going to connect with the database. Yeah. For that, we need a DB context class. So we are going to make a new class.
So we need to specify how, we need to actually make those tables inside the database, and then call the migrations to do it all for us.
Okay, so we have a product DB context class. So this class has to inherit from the DB context
class
from Entity Framework. Now we're missing a namespace, so I'm going to Alt and Enter here and say using Microsoft.NET Core, and then we're fine. Okay. So now we have to specify all the tables that we have. We here have an equivalent of a table would be a DB set. And we have a DB set of products, which is going to be called products.
Yep.
And we are going to have the same thing just for the categories. I'm going to call it categories. Now here we are missing a namespace, so we're just going to Alt-Enter, and it's going to import it for us. Okay.
Yep.
So now we've specified the tables, but we also want to specify how each column behaves. What is the ID? Maybe what columns are required. Maybe some have a limited set of characters. Let's say name can have 1,000 characters. Let's say it has 30.
And we're also going to specify the relations between those tables. So, like we said, products and categories have a one-to-many relationship. So we're going to do those two.
That's done by overriding. By overriding the method called onModelCreating.
Yeah.
And injecting, providing it with a model builder. Now, model builder is what enables us to build models. I mean, it's what it says. So model builder,
okay, let's make a primary key for, let's say, products.
Okay, so we do entity. That's what entity we want to use. So that's product. And then we say has key,
which will make a primary key for us.
And we provide it with a lambda that returns the property that would represent our primary key. This is how you make a primary key in Entity Framework.
Yeah, so let's do one more. Let's say the name can have a maximum of, 30 characters. Why not?
Yeah, okay. So we choose a property, okay? And then we say a product.name.
Yep.
And then we say, okay, it has a max length of 30. And it is required.
Yeah, that's also important.
Yeah. Okay, so this is how you would specify some column. There's a lot of methods that Model Builder provides us. You can, you can look at the documentation, which is, by the way, one of key things of .NET Core. Like the documentation is really super well written.
Okay, so now we need to specify the relationships between these two tables.
Yeah, so we pick an entity. That's a product. Okay, and then every product has one, category.
Yeah,
and with that category has many products. So that would be category.products.
Yeah.
So this is how you define a one-to-many relationship.
Yeah, so if we were to have a bigger database, we would have more relationships. And we're only going to do two things here, but you need to actually specify this for all categories or all columns. And we're going to show it to you later in the code that already works.
Yeah.
So now we need to show you what? Migrations, right?
No, we go to new code.
Yeah, okay, so we'll go to new code.
We're going to go to the code that we've already written because we would basically copy-paste a lot of this.
Yeah, so let's go back.
And we don't want to not save it. Okay, so this is our code. It's running actually, so because that's how our front end works.
So this here is the same code, but just it's finished already, and we're not going to bore you with typing boilerplate code. Yeah. So now that we can show it to you how it's actually done.
So just this method is what is used for to enable auto-incrementing IDs. That's what.
Yeah, it's standard procedure.
Yeah. Okay. So here, the DB context class, it can take options. So these options, which are injected through the constructor, tell us how to, how entity should connect to our database. So in these options, we say, okay, we are going to use PostgreSQL, and we are going to provide you a connection string to the database. This is what the options contain. This is all done through dependency injection.
Yeah.
So in order to inject these options, let's first go to
app
settings.json. Here we have a connection string, okay? And we will say connection strings for products is this whole sausage. Okay?
Yeah, a connection string, for those of you who are not familiar, it's a string that allows you to connect to a certain database. So you already made a database and you need to connect to it.
Yeah. So right now I'm going to make another connection string, but to a different database. So I will go to my database administration tool, and I will go and create a new database. Let's call it test. Okay, so we have it. And then in all this, I will use the same credentials. I will just replace
this one with test.
With the database name with test. Okay, it doesn't actually want to save. Okay. It did save now.
Now we need to change one more thing.
Remember when I told you that this is done through dependency injection, injecting the options into the constructor. So we have to go into startup and add this line. So we would do services.addDB context and provide it with the DB context that we've made. That's product DB context. Okay.
Yeah.
Okay. So inside it, we provide it with a lambda that takes options. Okay. And says options.use npg-sql. That means that entity should use a PostgreSQL driver.
As you can see this.
Yeah. And here in the brackets, we will provide a connection string. Now, because we don't want to hard code those strings into our code, that's why we type them in app settings.
Yeah. So now we need to change from products to test, right?
Yeah. So app settings. When we start the application, it builds a configuration class or object that provides all the entries in the app settings. So if you want it, if you come here up, you see that it's injected. This iConfiguration interface is injected into our constructor. So the idea is that this .configuration, that's what we set the configuration to. Then we use get connection string. That's going to get us this object right here. So we have two options to use to get the product, connection string or test one. In this iteration, we're going to use test.
We're going to use test because we would like to show you how migrations work. Okay, go back into dbeaver. We're going to show you that this test database that we just made is empty. And we're going to show you how migrations work. So it's actually going to make the database for us.
Yeah.
Okay, so you can see now it's empty. And now we're going to go and make migrations. You can just make them, right?
Yeah, so you go to Tools, NuGet Package Manager to get the Package Manager console.
Yep.
And then in the console, you type add migrations, and then you type the migration name, let's say initial.
Yep.
Then when you click enter, I'm not going to do that now because it's
we already have them.
We have already generated the migration. So if I enter it, it's not going to generate anything. But if you use click enter, it's going to make you another folder here. If you can see this migration folder. Now
inside it, there's that already looks like a SQL script.
It reminds you of a SQL. As you can see, you have columns, tables, table names, primary keys, etc. This is going to get translated into SQL, and then those SQL scripts are going to be ran on database. So
okay, now let's do those migrations. Okay?
So I'm going to type in update database, okay, and then it will build the scripts. And okay, so it's good.
So it's good. Okay, now let's go back to dbeaver and see if we've actually done something. Yes, let's refresh.
I have to refresh, and voila.
Voila.
We have a database. Basically, we didn't write a single line of SQL, and here
everything works.
Yeah, we have primary keys. We have the relationship with the foreign key constraints. This table is for entity framework to configure migrations and watch out what we have already implemented, what we haven't, etc.
Okay, as far as you can see, we've done everything from code. So this is an example of code first. Okay. Okay, so let's go back to the presentation. We have some things more to cover before we show you the rest of it. Okay.
Okay, so first the architecture. Here we are going to use a 3-tier architecture. So our architecture is contained with 3 tiers. Client tier, application or logic tier, and database tier. So our client tier would be a browser, native desktop app, or Android app, whatever. Our application tier is what we have written so far. It's going to be what is running on the server where all the logic is. And our database tier is going to be our database. So a tier is a physical separation. So all these tiers are running on different machines. So a client tier would be ran on our client's, mobile phone or laptop. The application tier is ran on our web server, and database tier can also be on the same server as the application tier.
But that's not common practice.
Yeah, usually you would separate these as well. So that's why it's the 3-tier architecture.
It's physical separation.
Yeah. Now, our application tier is consistent of 3 layers. Now, layers, they are logical separations. So all these layers are inside our application. We have presentation layer. That's essentially what first gets the request and decides what to do with it and returns a response. It's what communicates with the client. The business logic layer is where all our business logic is. That means if we have some business decisions that we that are crucial to our company, this is where we would keep them.
This is basically our app. This is how our app works. And the database?
Database, we have a data access layer that's its primary purpose is to communicate with the database. Now, all these layers are, they only know for the layer below it. So presentation layer only knows about the classes and the functions of the business layer. The business layer only knows about the functions and classes of the data access layer. For example, we can't call from presentation layer, we can't call methods in data access layer, nor can we actually from data access layer call, let's say, backwards the business logic layer. The data access layer only returns the data to the business logic layer. That's, let's say, from reading the database.
Yeah, so let's look a little bit about database layer. So we're going to show you this layer in code, but we have some data access repositories. They're called like product access repository, stuff like that. So why is this database layer important for us? Let's say our database here in our example is PostGRE or Postgre database. So let's say we're working on some project, and one day our boss comes up and says, "Hey, look, we actually made a better deal for some other database, but it's not Postgre, it's I don't know, MySQL, whatever." And if we didn't have this layer, we would have to change everything behind it. We would have to change a lot of code there. We would actually be in a lot of trouble. But now that we have this data access layer, we can just change a couple of drivers, something, only in one class, and everything will work just as normal. So that's why the database layer is super important for us. Okay, now we're gonna talk about a little bit about presentation layer, right?
So the presentation layer is where the request first arrives. So it's consisted of controllers and views. So the controllers are really what's important, let's say, about the presentation layer, because they decide based on the request method and the request URI what function of business layer to call. So when they get the request, they decide what to call. They call the business layer, and the business layer returns some models. Those models, so for example, the ones we have about the
products and
categories, are then returned to the presentation layer and mapped to views. And then those views are returned
back to the client.
So the idea behind this, we could have easily as just returned the model itself to the client. But let's say we make a banking app, And our model is a model of a client that, or I mean, a person really, that has their, I don't know, social security number.
Yeah, which is private.
Yeah, and if we return the whole model of a banking client person to the browser, whoever is consuming our API, they would get the social security number. Now we could get sued for that because we can't do, that's confidential information. So what we do instead is we take this model, okay, and then map it to a view model that's essentially the same. It's a product, it's a client person that has all the same properties but doesn't have the social security number.
So it basically omits some information that could be confidential to our business. Yeah. So in this case, it could be a social security number.
Yeah, and then we can return that to the consumer of our API.
Yeah,
that way we control what is what our consumers can see and what we keep to ourselves.
Yeah, so let's go back to code now. Let's show them everything. Let's show them how it's all done.
Okay.
So now we can start with this data layer access. Like we told you, we have some repositories. We have this category repository and product repository. And those are for communicating with the database. So we have in data access layer, we have models and repositories. And now let's go to the presentational layer. We have controllers and view models. Okay, so what are we going to talk about right now? Should we talk about repositories maybe?
Yeah, we're going to cover repositories. So here, this is where we get something. Let's say in the product repository, it's already made, so it has injected the product DB context. That way we can communicate with the database through the entity framework. And we have some methods, for example, get all to get all the products from the database. They get by ID. We provide it with ID, and then it finds a specific product with that ID from the database, and then we can also add products. For example, let's say that now I want to add.
So we're going to add a new feature that isn't in this one, just to show you a proof of concept.
Yeah.
So what we're going to add?
We're going to add a method that gets the top 2 products ordered by name.
Yeah. So a super easy one, just to show you how it's all done. So just to get you through all the steps.
Yeah. So then we would return. So this this interface IEnumerable essentially means that we can loop through it. Loop through it. It's a list is an enumerable. We can loop through it. An array is also an enumerable. So if you wanted to make it easier, what it is. So we use a context. Then on context, we decide we're using products. Okay.
Yeah.
Then what do we want to do? We want to take 2. So this will take 2 products.
Top 2. Yeah.
Yeah. And then we are going to order them. So we go ordered by. We can go descending or normal, ascending, the default one. So we say a product and we want to return a name.
What? Yeah.
Yeah, we're live.
Okay, sure.
I mean, the chat is not really.
The chat is bugging. Never mind.
Okay, so in the end, we want to convert it to a list. So this would give us something that is like a query. And then we want that query to be converted to a list so that we can actually use it. So this is how you would make some method from the repository. We also need a controller. So let's just go
back to the presentation layer and then into controllers. Okay?
Yeah, we have a presentation layer, controllers. Let's say right click and we want to add a new controller. So here you have MVC and API. We want API. And let's say I want API controller with read and write actions because it's going to generate a lot of code for me, which I won't have to. So let's call it the top 2 controller.
Yep.
Okay, so here it is. So as you can see, this is a class with some methods, but it also has these weird things in brackets that look like arrays. These are not arrays; these are attributes. So these define some additional information about our classes. So
to the entity to the .NET framework.
Yeah. So this is so that the .NET framework knows, okay, this is an API controller, and it has a route of our domain /API / and then it will take. This means that it takes a controller name. Here, if you see the methods, it also has an attribute HTTP GET. That means that if we accessed API /top2 controller, the name, it would be API /top2 with if we send a request there with a GET method, it will run this method. Okay, so since we want to get some information from the database, we want to inject a repository, private read-only product repository, we're going to call it. Okay, so we have to
inject it, yeah. So to import it.
Yeah, we can use Zutor to make a constructor, and then we would take this. So we use constructor injection, dependency injection, and say this dot repository equals repository.
Yeah. Okay. So our chat is lagging for some reason. So, never mind.
It's not lagging. It's actually not showing it.
Not showing anything. Yeah. Never mind. Let's see what happens when we call this HTTP GET method. What do we need to do in order for us to return the top 2 value?
So we use this dot repository dot. So we have the get top 2 by name.
Yeah.
Okay. So as you can see, it's red. Why? Because this is returning an enumerable of products, but here we are returning an enumerable of strings. So remember when I told you that we want to map our models to the view models? Well,
yeah, let's show them the view model.
We have already made view models that are basically the same as our product models. You still have description, name, description, ID, category ID, and also we have a reference to the category view model. Same thing here.
Yeah, so this is the same as we have nothing to hide, since we don't have a business logic.
Yeah, okay.
Okay, so now let's return not products,
but product view. Okay.
So this is a good practice, Yeah.
And now it's again red. Well,
yeah, because we're missing a cast.
It's still missing. This is still returning an enumerable of products, not an enumerable of product views. So I'm going to copy a part of that's going to convert
this into a new product. Oh. Okay.
That's going to convert these products into
yeah, this is just your no, it's okay.
It's okay.
Yeah.
So this is going to, so what do we have here? We have a list, and then we use a select method that's going to
populate
take every product or every element of the list, and then it's going to make a new list based on what we returned here. So we return a new product with the same name as the product from the list, same description, same ID, but the category, we have to make a category view that has the same name as the product's category name, and etc. Okay, so I think we are done. So let's try it out. So on this here, we can run the project. So okay, yeah. So I guess it compiles and works. Okay, here, as you can see, we have this UI. I have import, when you first create the web API template, it also installs this package called Swagger that, based on your controllers, it's going to generate this UI. So you can actually run, you can execute requests or send requests from here. So we want to test the get method on /API/top2.
Yeah, just so you know, guys, we're back in chat since our chat is lagging here. So we're back in chat through phone.
Yeah.
Okay. Okay, let's see if this works.
Okay, so we will go try it out. As you can see, this is like the whole schema, what it's actually very helpful. This is what it will return. It's not the same, but this is how it will look like.
Okay,
So
let's execute.
Okay.
Nothing.
Yeah, I know why it's nothing.
Okay.
Remember when we made migrations, we went into startup and used a connection string to the database test.
Yeah,
now
so we actually made this mistake.
Yeah. So what we would do is use a product.
It's
connection.
I think.
Products connection string. So this right now, what it's going to do, it's going to use our database that we already made and pre-populated for
data,
this. Yeah.
Okay, let's start it. We might still have a mistake.
Yeah,
We'll see.
Yeah, I don't think so.
You don't think so? We'll
No.
see.
Oh, damn.
Okay, so another mistake for us. Okay.
But I mean, this one was calculated. The last one wasn't. This one we expected. So what is happening here? Well, basically, we have this list of products. And when we try to access a single product, when we try to access the category through p.category, this category is null. So what it throws the null exception, null reference exception. Basically, we try to access the property, name from something that's a null, that's not an object.
So there's a quick fix for that. There's a quick fix for that.
This is happening because Entity Framework didn't populate the category the category property of the product model. So what we are going to do, we're going to go into product repository, and then we'll say here, right before the lists, the two lists, include, and then we say what we want to include. So we want product and include product.category. And now this should fix it.
Now this should work. Okay, so if we make a next mistake, this one was not prepared.
Yeah. So we go here, we try it out, we execute it.
And
yeah, it works.
Drum roll, it works. So as far as you can see, we have an Audi IA t-shirt just like we had in that front end that we actually.
Yeah, okay.
So this should be it, right? This should be all the code.
Yeah, I also wanted to touch on one other thing that we didn't mention.
Yeah.
So we talked a lot about dependency injection, but we didn't really show you how you can register services for dependency injection. So we are going to go into startup, and we are going to have a look at these two lines. For we go services dot add scope or add transient, and then we provide it with an interface and with its implementation. In our case, it's the same, but usually you're going to use an interface here, and then here you're going to use its implementation. Now, there's add scope and add transient. So the difference between these two is that an add scope is basically, it instantiates one object for one scope. That's, we open a scope per request. So we will have one product repository per request. And if we use the add transient, we would, every time we would inject a product repository,
yep,
we would create a new one.
So that's why we use that scope.
Yeah, right now it doesn't really, because we do not have any shared state. It's the same if we use add scope or add transient, but sometimes,
just so you know about what options are there.
Yeah. DB context by default is add scope. So it has to be one per request because it's very expensive to
get a new every time. Yeah. Okay, so this should be it from our code. Let's go back to the presentation. Just so you know, this is everything. We wanted to highlight out some key points. So we would like for you to, after today, we would like for you to know what is ASP.NET Core and why do we use it. We would like to know for you to know what REST API is and how to start making one. We would like for you to learn what inversion of control and dependency injection is. Those are two super important topics. And the layered architecture or the tree-tier architecture. what entity framework is and how do we use it, and the warm and cold first way. And we actually hope you had fun.
Yeah.
We hope we didn't bore you to death. We tried to make it in under an hour, 50 minutes.
Yeah.
About so that should be it.
Okay. So
if
you have
any questions, we'll read them from phone.
Yeah, because the chat isn't working for some unknown reason. Like
Yeah. So if anybody has a question right now, this would be the time. No questions so far. Anybody on how we can improve this solution?
Okay. I mean, I think it's lagging like 10-ish seconds.
Probably.
So let's wait. I mean, we've basically done a lot faster than
we
expected.
No questions.
Okay, so there are some things that we obviously omitted. So let's say if you remember the talk about architecture, we don't have a business layer here because we do not have any business logic. But this is not a good practice, okay? Because at some point, if you have a product, something to sell, or some service, you are going to have some business rules. So you should always make a business layer to separate and loosely couple your system. Basically, we did not do this today because our business logic layer would consist of calling just one line methods that call data access layer. So
but in practice, they usually
that's not a good practice at all. For all intents and purposes, today we have cut some corners to introduce you to C# and .NET Core for you to see if you like it, and then research on your own.
Okay, this is the end. Thank you guys for watching. We were Red Tech, and we were talking about ASP.NET Core, and we would like to invite you to our next lecture on Saturday at 6 p.m. I'll also be your host, and we'll talk about Spring and Spring Boot and why the easy way is always the right choice. That's it for today, and thank you all for watching. Bye-bye.
Bye, guys.
Bye.
Thank you.
See ya.